All right, friends, we are wrapping up the digestive system. We are starting with the small intestine. So as food comes into your stomach, you have your acid and your chyme that get emptied into the first part of the small intestine called the duodenum. The duodenum goes from the pyloric sphincter all the way to the duodenojejunal flexure. Yeah, that's fun to say. Something else that you see is that the bile that is stored in the gallbladder or made by the liver comes down the bile duct and joins up with the main pancreatic duct to empty here into the duodenum. So this pancreas produces a whole bunch of enzymes and buffers to balance out all this acid that's coming in here. It actually makes it a little basic. And so these enzymes also start breaking down as those bile salts come in and also start breaking down those fats. So a lot of breakdown happening in this duodenum. The duodenum is pretty short. It's only about 25 centimeters long. And then from this, here you can see that jejunal flexure. It becomes the jejunum, which is about 1 meter long, so about 3 feet of the jejunum. And then the jejunum wraps around and it turns into the ileum. How can you tell the ileum from the jejunum? Well, you have to look at it histologically. You really can't look at this and be like, oh, that's jejunum and that's ileum, just based on a gross anatomical look. You know that the ileum is going to be the last part, so the part coming up to meet up with the cecum. But where that change between jejunum and ileum happens, it's really hard to tell. So if you look at it histologically, the ileum has this stuff called Peyer's patches. Peyer's patches are basically lymph nodes in your small intestine. And so this has a whole bunch of lymphatic tissue, white blood cells are in here. And so it helps to keep all the bad bacteria away out of your body, down here at the ileum. So the ileum is about 2 meters, so about 6 foot, give or take, and it goes from the jejunum all the way to the ileocecal junction, or the ileocecal valve. So there's a valve right here that allows the food from the intestines to be emptied into the cecum. And it won't open unless this area at the ascending colon is clear. So there can't be food here at the ascending colon, because if there is, this part won't open up, right? You'll just start getting all backed up. So you got to move the stuff through the colon. If you look at the small intestine, so if we cut into the small intestine, we can see that here you can see your layers, right? Submucosa, submucosa, muscularis, serosa. Inside the lumen of the small intestine, we have these circular folds. And these circular folds just help to slow down the chyme as it moves through here. It also increases the surface area via these villi. So if you look at the villi, they're kind of like these finger-like projections that stick out on the surface of the intestine. And on these villi, you're going to have these enterocytes, or the absorbing cells. So these are all simple columnar when you look at them. And they're going to be the ones that are going to be absorbing the nutrients into your blood. So you can see those capillary networks. So you absorb the nutrients into the veins to go on out. Something else you see are these lacteals. So these lymphatic vessels reach up in here. So the capillaries of your arteries and veins really have a hard time bringing in these big droplets of fat. But the capillaries with their little flap system can bring in a lot of those fats. And so most of the fat that you bring in through these lacteals, and that puts that into your lymphatic system. They call them lacteals because if you look at the lymphatic fluid near these, it looks really milky. So like lactose, right? So it looked like milk, and so they called them lacteals. And then your lymphatic system then goes up and drops all this lymphatic fluid into your subclavian veins to return it back to circulation. And so those subclavian veins have a lot of fat in them compared to your other veins, because that's where it gets dumped from the lymphatic system. And then you also have microvilli. So if you look at it, oh yeah. Oh, leave that there, move me. That's what we try to do. Okay, so you also have microvilli. So even smaller little extensions, finger-like extensions on the individual cells, not groups of cells like your villi. And it forms this thing called a brush border. You have a bunch of enzymes on there that'll break stuff down via contact digestion. So as a sugar molecule comes by, it'll hit this enzyme, and that enzyme will split it into two different molecules. It'll take like your disaccharides and turn them into monosaccharides, so 2 sugar units into 1 sugar units. You also see these intestinal crypts. So here's your enterocytes, those things that are doing the absorbing, but at the bottom of it you'll have these Paneth cells, and they secrete lysozymes. And we talked about lysozymes before when we were talking about salivary enzymes, and how lysozymes are antibacterial enzymes, enzymes that break down bacteria. And so if bacteria get down here, these Paneth cells will kill them. Something else that they secrete is phospholipase. Anytime you see A's, you know it's an enzyme. Phospholipase breaks down phospholipids. And so this is another way that it can fight bacteria, is by busting their cell membranes open and letting their insides leak out. And then we have some other defensive proteins that are associated with this. So these Paneth cells really help to protect the intestine from infection. So looking over again, we have those folds, you have your villi, and then on the individual cells, you have the microvilli. So it kind of looks like that. So the stomach has, or the small intestine has 2 ways to contract. It can do this contraction called segmentation, where it just kind of, your circular muscle just kind of pinches off, and it allows for mixing of your chyme that is in the small intestine. And so it helps to cut and churn stuff. So hopefully these areas that are near the center will make it to the outside and come into contact with that brush border, so any stuff that is in there can get digested and absorbed. But normally when we're talking about moving things in the small intestine, we talk about peristaltic contractions. And we talked about that earlier when we were looking at the esophagus, and how you have that contraction of the circular muscle, and then you push forward with the longitudinal muscle to move it through. So when you have food in your stomach, it can cause a relaxation of the ileocecal valve. So anything that you have in the small intestine can now move out if there's room, right, in the cecum. If there's not, then nothing's moving anywhere. But if there's room in the cecum, then the small intestine will clear out, so the food in the stomach can then move in. So 3 structures that increase the absorptive surface: microvilli, villi, circular folds. The difference between segmentation and peristalsis: segmentation is just the churning of the circular muscle, where peristalsis is the pushing of the food or the chyme. So as your ileum comes into contact with the large intestine, it's going to come into contact right here at the ileocecal valve, saying you have your ileum and the cecum here. The cecum's just this blind-ended pouch where you have your vermiform appendix, and then you go into your colon above that. The vermiform appendix is just a place to harbor helpful bacteria. So we have 75 trillion cells in your body. Only about 35 trillion of those are your cells. The other 40 are going to be bacteria cells. And a lot of those bacterial cells are helpful. And so we're learning more and more about your gut microbiota and how important it is to have the healthy ones in there. Some people have started doing fecal transplants where they take poop from somebody else and putting it into their intestine so they can get that healthy bacteria. So your appendix is thought to harbor that healthy bacteria for you, not just to kill you. So if you get something like amoebic dysentery or explosive diarrhea, that really kills a lot of the bacteria, gets rid of a lot of bacteria that's in the colon. And they think maybe that appendix will then allow for those good bacteria to come back and colonize after the diarrhea goes away. But that hasn't been proven anywhere. It's just the thoughts. All right. So, ileum to the cecum. And then you go into your ascending colon. The ascending colon goes up. And then you bend and use your transverse colon. And you bend and your descending colon. And then that descending colon turns into the sigmoid colon, looking like an S. And that leads to the rectum. Your rectum has valves. If you look, you can see how this one kind of pushes out there. That one kind of pushes out there. There's these things, they're called the valves of Houston. I don't know why. Probably because some guy named Houston discovered them. But what they do is they help dissipate the force and the weight of the feces from just trying to really push out your butt and give you that urge to poop. So these valves slow that down. So here you can see those valves again. Your anus also has, or your rectum also has anal columns, so you can see these pieces coming up. And then these grooves right here, which are called anal sinuses. And there's a lot of vascularization going on here. These vascularizations, these are your hemorrhoidal veins. You may have heard of hemorrhoids before. Hemorrhoids can be internal. So here is where your sphincter is. And if it comes to the outside, it can also be external hemorrhoids, caused by buildup of these vessels out here. Your anal sphincters, we haven't talked about the urinary system yet, but they act very much like the bladder, where you have an internal and an external. The internal sphincter is smooth muscle, so it's involuntary. This is when poop gets down here and this internal sphincter relaxes or gets stretched. It's going to send a signal that, oh, you have to poop. But you don't just poop right away, because this external sphincter is skeletal muscle and you have control of that. So this is that release valve, right? Is your external one, the one that you control. When stuff moves through the large intestine, it moves via these units called haustra. And so the haustra can push and move the poop through, or the feces, poop, whatever, through your large intestine. Every day, you have this thing called a mass movement, where you have this gastrocolic, talking about the stomach and the colon, and the duodenocolic, talking about the duodenum and the colon reflex. And so when food comes into your stomach after there hasn't been food in there, so you empty out the food, new food comes in, that stimulates the pylorus to release the sphincter, and so food goes into the duodenum. When food goes into the duodenum or goes into the stomach, you also have that release of the ileocecal valve, so anything in the small intestine can move it to the large intestine. And when that happens, you have this gastrocolic reflex where you really move a lot of that material that is in the large intestine out. And so this happens 1 to 3 times a day, depending on how empty the stomach gets. And the most common time for this to happen, for these large mass movements, is right after breakfast. So when you eat breakfast, your stomach is empty, that food comes in, causes that duodenal colic and the gastrocolic reflex to open up the pyloric sphincter, to open up the ileocecal valve, and to move all that stuff through the large intestine out into the rectum. And so when you have breakfast, after breakfast, you'll probably need to poop. Especially if you drink coffee, because coffee is a diuretic and actually can cause you to poop. And so if you have coffee with your breakfast, expect a mass movement. And with that, we are done with the digestive system.